afternoon, everyone. Yeah, well, you say we're talking about the first webinar, the use in genomics now and the future in aquaculture. And then, I have for some presentation they got before. It's Antti, who makes the black box approach of the aquaculture. Now Sigborg with the functional notation and precision breeding, the topics of AQUA-FAANG. And then now I will explain you our vision or our scenario from our company, Geneaqua, it's in Spain. And then Romain will add more information. I am Adrián from Geneaqua, this is partner 22 of Spain, and we are involved in the work package 7 that we have for the diffusion of the results, and also made a link with the breeders and the aquaculture facilities. We are a small enterprise for genetic technology for aquaculture, and we are genetic advisors focused on genomics and breeding programs in different aquaculture species. But we don't know spawn our fish. We are advisors of the producers of the farms, and then we try to improve their own stocks. We work with the fishes of the companies and then help them to select the better for their results that they want. And when we join AQUA-FAANG, it's very, very nice for us because it's involved in research that's highly relevant for our goals for aquaculture genetics. And also we want to improve our knowledge in new techniques to offer them to the aquaculture companies, mainly related with growth and also disease resistance that the companies want to increase or to improve. And then, we have 2 different presentations before. Using genomics now, more or less, in aquaculture, it's a little summary of the Antti-Kau's talk. That is the different steps that the history of the genetic genomics in aquaculture. The first is the pedigree-based selection, then the genomic selection, the money balance, genotyping and fishing pedigree. The single-step genomic evaluation is more interesting now. Probably use some QTLs in the breeding value evaluation, but with a lot of thousands of markers, we have covered all the genome. And sometimes you use some QTL info, snip picking, aquaculture breeding. And this is now all the things that you could do with aquaculture. And now for the future, the AQUA-FAANG is working on these topics, like they said now, displaying Sigborg. But I want to put the focus in another thing, that not all the aquaculture species, so not all the aquaculture companies are using genomics right now. Yeah, it's not easy to use genomics for some companies, and then I will explain what we are working with different companies. But I think that it's good that we take in account that probably we have different scenarios within the different stakeholder or the aquaculture companies. Because with some big breeding companies, the example of the Atlantic salmon, like, I don't know, it's Mowi or Aquagen or something, or Benchmark, companies that they do their own research and participate in big public projects, public and private also, of course. And in the salmon, you have more than 7 generations of growth selection. You have direct crosses. You have enough budget for genotyping. You have some QTL info like the IPN resistance that is very successful. Or now it's making genomic selection that's improving the genetic selection, and is very more for complex traits like disease resistance, like now sea lice or others. And then in the future, for underlying the function of genome regions or knowing exactly what to do, the salmon are working in gene editing, CRISPR, to change some parts of the genome and then get in 2 generations a good response. But another scenario that what will remain with the next invited stakeholder to give feedback are sometimes national producers associations, as the CISAF, that their own research and participate also in big public projects that make the technical support for all the French aquaculture breeders or to interested parties to implementation of the genetic breeding programs, no? And then they have a lot of very good research and very good programs to put in value. But like us, this is the small breeding companies like Geneaqua, we are advisors of the producer. We try to improve in their own stocks. And it's very, very important, and they take account always that we are working with companies, and then they need a good balance between the cost of genetic analysis and the ratio of improve of the production. That is very, very linked to the size of the company, no? Because if you pay more than 100,000 euros for genetics, but you are only producing 1 ton of fish, probably is not a good balance. And then when the companies have a big size of big production, they could afford the cost of genetics. And then we have different situations, different customers, and then we have to work now with genetics and genomics, but in a tailor-made breeding programs, depending on the company that we are working with, no? And then, our company, Geneaqua, we're working with different species, with different levels of genetic or genomic information available. We have the tarbot, the sea bream, bass, rainbow trout, Senegal sole, and also mollusks like mussel, clams, shrimp. But we use all the genomic resources available from different projects, or the other own resources with industrial projects or you make in collaboration with the companies, but it's secret, more or less secret research, no? But also for the some projects of AquaTrace, FishBoost, Mayday, AQua-FAANG, we are very, very taking account these projects, this genomic information, this genomic resource, and we pick the things that we could use for the companies. Some farmers are the best interesting, or the main interests of the farmers are the growth, to improve the ratio of growth. And that's, well, probably you have a classic selection or pedigree selection. We hope they have a good irritability. And if they don't have a lot of money, I think it's a very, very good first step, because it's for growth is going well. But when you have much more money, the first step of genotyping, they use companies use some markers like microsatellites or a few SNPs to make the family a segment. You know, you have the genetic profile of the breeders, and then the different offsprings, and then you put the family segment and put selection with phenotype and genotype family selection with the black. But, well, it is making this, we don't know, in Senegal sole probably now, but in the next generation sequencing, we could get new genomic resource, no? Like with the RAD techniques for genotyping by sequencing, or also the whole sequencing individuals to get a lot of genomic resource for genotyping. And then if you got this possibility to get a lot of SNPs per in the whole genome, you could make the genomic selection, no? Also, genomic selection is better for complex traits, and then we are using genomic selection with some species like rainbow trout or tarbot, but you have more information about the genomic resource for also disease resistant or other complex traits that is linked to fecundity or also with fillet or some traits like this, no? But for the future, also, it's very, very important, the cost effective, and then we are trying to get new different panels or chips of SNPs with different density, low density, medium density, high density, using the imputation, no? And then you could get the high density SNPs, the high density genotyping with the parents, and then with the low density with the offspring and imputation, and make, because it's very, very important for the companies to save the budget and use all the more number of individuals than they can afford. And also another thing that we are making for this cost effective is making like multi-species chip. Ne? We are combining, we are designing new SNPs that combine different number of SNPs of different species in the same platform, in the same chip, and then we could offer this chip, the multi-species, for different companies, for different species, for mollusks, and also for fish together. And then it could make the increase in the number of samples we could make per year, and then the less price per sample for the companies. And then it's good for us also, and good for the companies, because you combine different species, different companies. Every company get only the information of this species, of course. It's very confident, the transfer of information. And then, but it's not the same that a company make 2,000 turbot, another company make 10,000 rainbow trout, and then we made the same chip for 12,000 individuals, and then it's better the price per sample for all the species involved, no? And also, well, the future probably is using the QTL info or SNP picking. And we are working on different species and different diseases, like in turbot, and also with parasites, with some problems with bacteria, and also with rainbow trout in different virus, bacteria, and other things. But we are trying to use the genetic architecture study with the GWAS, but well, it's good to take into account, but it's not easy to get the success like IPN get. Yeah, the IPN, yeah, it's very, very nice information, but it's not for all the species, not for all the diseases have the same. And sometimes the companies, the farmers say, well, I have to try like this, but we have to make some studies of genetic architecture and GWAS to know if they have some things. And also, well, of this project, the knowledge of underlying functions, very useful for focus all the efforts. And then for the using genomics in the future, for AQUA-FAANG is working on functional notation and precision breeding. And then I think it would be improved and be implemented in the future, that we could offer to our company, our customers in the next future, right? And then this is our situation now and the situation for the future. And well, thanks for your attention.